reason for the screen you see is if you'd like to share data with me live, get graphical analysis on some device, preferably not the one you're watching the webinar on, maybe your phone or something, and you can get the data live from me as I collect it. So that's why I have that boring screen up there. Just go to vernier.com, down under downloads. You can get graphical analysis for free, and we will pro you up, so you will be good till September. I think somebody in marketing liked it when I said pro up.
Yeah.
It will pro you up.
And if you all are installing graphical analysis and you run into a problem, feel free to let us know in the chat. It should be set so that anyone can chat in there, so feel free to let us know. I think I saw someone raise their hand. And just to break the ice, go ahead and let us know if you've been to a Vernier webinar before, or if this is your first time. I always kind of like to see who here is joining us for the first time. No worries, Kimberly.
That's all right.
Nice to see you again, Chris. Thank you for joining us.
Anyone going to ChemEd?
Oh, yeah. Welcome, Laura. Very cool. Awesome. Well, it looks like we've got some first-time folks and some folks coming back. And I will hand off the webinar to Nus here in just a second. But before I do that, I just have a few small pieces of housekeeping to get to first. First and foremost, you will receive a recording of this webinar. We'll go ahead and email it to you as soon as it's up on YouTube and the website. So keep an eye out on your inbox for that. In addition, I would love to answer your questions today. So please feel free to use that chat box that we were just working with just a moment ago. Feel free to ask your questions in there, and Melissa and I will keep an eye on that and help out wherever we can. If for whatever reason we don't get to your question, we'll follow up with you, or you can reach out to us at chemistry@vernier.com and we can help you there. And with that being said, I'll go ahead and pass you all off to Nus. Thank you so much for joining us.
Hi, everyone. My name is Nüsret Hisim. I'm in the chemistry group here at Vernier. Let me hop. I think I have a little biographical slide here somewhere. There we go. So I taught in Maryland for 34 years, chemistry and physics, and used Vernier equipment almost from the time David started the company. I'm now here in near Portland in Beaverton, Oregon. And I do some teacher training, and I do help write curriculum, and do a little tech support for folks, and I do webinars and conferences. So that's my job. Melissa, you want to?
Yeah. Hi, everyone. I'm Melissa. I'm also one of the chemists here at Vernier. There's three of us, me, Nus, and Elaine is our third chemist. We all kind of wear a lot of hats and do all the same things that Nus was describing. I'm here to answer any questions and to keep Nus focused. So if you have any questions, again, please throw them into chat and we'll get to them as soon as we can, or I'll interrupt Nus. But yeah, that's all I have to say.
So what we're going to do, and I mentioned this earlier, if you have the option to put this graphical analysis on another device, it would be nice because then we can also demonstrate this cool feature where we can share live data across the internet or anyway where you want. And so that's an option, but so just go to our website if you want to try this with the device, and go to vernier.com, downloads, and you'll see graphical analysis right there. And then we'll make our copies together. We'll make them pro here in a minute. But anyway, we're going to do today, we were trying to when teachers come to a webinar, in the middle of the summer when they're probably at the beach or whatever, what would be something sort of fun to do? And this is has to be probably one of the most fun experiments to do for kids and for you. It's just what is pH, but more importantly, how can we tell the difference between acids and bases, and in kind of a fun way. Red cabbage is just amusing. I used to make it in the classroom right before we used it, and just with a blender and some water, and so that's we're going to tie those two things together. The use of an indicator and also using the probe, and so something relatively simple. So that's what we're going to do, but we're also going to, if you're a user of our experiments, the older versions of these experiments use the pH probe as a meter, and back in the day when pH probes might have been more expensive or something, that might have been an option, especially if you already owned the software and the probe. But I modified the experiments and I shared this with you, and in this shared files folder, which we can put in chat if you want to take a look at it. But it's also going to be you're going to get links to all this stuff too. So if you just want to pay attention and not bother right now going into the folder. Yeah, we're going to go over. I modified the experiment so that it's events with entry, so it's not just a meter. And the newer version of graphical analysis, the pro version, also gives you the option to create bar graphs, which the free version does not. So we're going to look at how do you do that, and then also remote data sharing, and at the same time do something sort of fun. My students, when I used to do this, they would, once you started doing it, they were like, can we try this? Can we try that? They really wanted to do their water, and we'll talk about water here in a minute. So for this experiment, go direct sensor. It doesn't have to be a go direct sensor. Let me bring my camera up here. It could, I have two here. Mostly I overplan just in case one of them doesn't work the way I expect, but this is a flat pH sensor. This one it's a little more expensive because it's what they call a double junction sensor, but it has a very flat tip. It still has glass, it still can be broken. But that one's a little more expensive, but functionality wise, it's identical to the other pH probe. The other pH probe is the one that we've been using forever. The difference is lately we have them in two pieces. So when the students, did you hear me say that? When the students break the glass bulb on the end of the electrode, you don't have to buy the whole sensor now. You can just buy the electrode. And then, little things, common things you're going to have in your classroom. I set up the stuff in the experiment, but I also have some extras over here. We'll watch the clock and we'll see how close we get. And then, you can do this with a go direct sensor. The beauty of it is you can do it on any platform. So you're not limited to computer with Logger Pro or something like that. You can do this with your phone, so it's kind of a neat way to do things. Let's pro you guys up. So if you've got graphical analysis on another device, fire that up. It'd be ideal if it was like not the one you're watching me on right now. And once you start if you have a free version of graphical analysis, this box down here at the bottom where it says activate additional features, that's going to be blank, or it's going to say like 1, 2, 3 or something like that. I'll put it in chat just in case somebody wants to try it later or so it comes. But what you do is just put that code into that box and then tap submit, and your free copy of graphical analysis will become the pro version of graphical analysis. And I'll show you, I'll highlight the features that we're taking advantage of today, so you can get a kind of a feel for it. That code, let me hit submit on mine here. That code will give you graphical analysis to the end of September, graphical analysis pro. And you're welcome to use it with your students. Okay, so if you want to try it when you get kids, later, I know you don't want to think about that right now. But yeah, if you want to try it and see, if you like it, it's to get the extra features, there is a license fee required. This experiment can absolutely be done without pro. The difference being that you can't type in the names of the substances. You have to number them, and that is something that back in the day I used to do. So I created a copy of a data file that I used to use, and it's right here in this shared folder. It's this data table, and what I did was I would use this when I was first starting to talk about pH, because it's just such a fun activity. But also, how's pH related to hydronium ion concentration? So I would have the kids work through, because for a lot of kids, once you get into this logarithmic type stuff, it's depending on the level of students, it can be a little challenging. And so I made this table. And this was back in the day when I didn't have the ability to type words in. I said that I had to type in numbers. And so, this was the way we would keep track of what the students were doing. Now with J Pro, the fact that you can type words in, boy, that really makes things a little bit different. So let's go ahead and get started on the experiment. And then if you have any questions, please don't hesitate to zap them over at Melissa or Dylan. So what I'm going to do is, with these Go Direct sensors, if you push on the power button, they start to flash a red LED that indicates that they're ready to connect by Bluetooth. You can also connect them with a USB cable to anything that has a USB port, so a computer or Chromebook. So let me go ahead and connect that one to my to my copy of graphical analysis. And so every sensor, you can see I'm in the office and there's a whole bunch here. Every sensor has a unique ID number on the back. Mine ends at M7. So without searching the list, if I just type M7 in here, it narrows it down pretty quickly. So now most of our data collection will default to time-based data collection. And certainly for this one, that's just not good. So what I'm going to do is I'm going to change my data collection mode to what's called events with entry. So I'm going to tap, by the way, all these instructions are on the handout, so don't just watch and enjoy. I'm going to tap in the bottom where it says mode, and I'm going to change from time-based to event-based. Okay, and the event is going to be called sample. And then I'm going to tap on done. Okay, so now the system is switched over. You can see it looks a little different with the collect key and so forth. I kind of like to have a bigger pH meter. There's a little itty bitty one down here, but my eyes are old. So I'm going to turn on a bigger pH meter so we can see what's going on. The probe is in the storage solution, which we're going to talk about here in just a sec. And so this is pretty close to ready to collect data. What I'd like to do is I'd like to share that with you. So if you've got your copy of GA ready to go, I'm bringing my iPad over here in a sec when I get hold of it. There's my iPad. It's sitting on the table here, but this makes it easier so you guys can see it. Oops, it was there. There we go. Let me see if I can zoom him up a little bit. So if you've got your copy of GA going, and it's all pro'd up and everything, tap right here where it says data sharing. Okay, I'm going to do that on I did that on my iPad. And then right here, you see two tabs. If you've pro'd up your copy of graphical analysis, it'll go to the online tab by default. If you don't have GA Pro, it goes to the local tab as another way of sharing data using a LabQuest. And so this is where I want you to leave yourself for just a minute. Okay. What I'm going to do is I'm the source of the data. Maybe you have 3 lab partners and one of them is collecting the data and sharing with their lab group. Or maybe somebody's at home and he broke his leg, and so the lab partners will share data. Or in this case, I'm the source of the data and I'm going to share my data with you. So up here at the top, I'm the source. There's a little, looks like a TIE fighter from Star Wars, right? I'm going to tap on that and it's going to start what's known as a data sharing session, and it's going to give me a special code that I share with my lab partners, in this case you guys. And so this code, make it bigger there, is what you need to type in to your copy of graphical analysis. So on my iPad here, I'm going to type in that code. Now, a little behind the Vernier curtain info, these, programmers are not classroom teachers, right? And so they used to have all kinds of wacky characters in here. And those of us that are teachers said, you can't do that. We can't be doing capital and underscore and that'll be crazy. So the programmers listened. So they made these, so they literally made these codes so they would be easy to put in with your finger, you know, just because it was like, gosh, it was like, at first it was such a pain. Now, if it worked, you're going to see pH and you're going to see sample. Okay, so we're ready to go. One thing I neglected when I was setting up the experiment, and we'll learn together right now. If you put in numerical data, it will put dots in. If you want it to do bars, and so this code, let's put this in the chat. Let me copy it. I'll put it. Oh, someone did already. Thank you, Melissa. She's way ahead of me. I'm going to set up this thing to do 2 bars. We'll talk about it in a second. And the edit graph options, you don't need to do this. It'll come up automatically on your end. But here where it says points, I'm going to change it to bars. I put this in the instructions of the experiment. If you start out putting in word, data that's words, it will automatically do that for you. But it's kind of nice to have that set the way I want. So this is ready. What I want to do is let's get my pH probe ready. I've got a bottle. I'm going to get my iPad out of the way because you guys don't need to see my iPad. If you've got Pro going, then you'll see all this anyway. So pH probes. What is the Achilles heel? There's 2. One's minor and the other one's not. The minor one is the storage solution. Your students are going to knock these bottles over and lose that storage solution. And it is not water. It is a pH 4 buffer with potassium chloride in it. We sell it. You can make it yourself. There's nothing to it. Send me an email and I'll send you the recipe. But honestly, there's pH 4 buffer, 10 grams potassium chloride for every 100 milliliters of solution. I keep a little container of nickels. I used to have these in my demo table at school, and then the students get used to it. And then what happens is when they knock the bottle over, you don't lose the storage solution. So keep a few nickels in your demo table and just, have those handy for the kids. The other Achilles heel, of course, is the glass electrode, a glass bulb on the end of the electrode. The beauty of the GoDirect sensors is that when the students break that, we used to lose 1 or 2 a year. You can change just the electrode without having to buy the whole thing. So it's kind of a nice little feature of the GoDirect sensors, although we do have them in the wired version as well. So that's ready to roll. Let's do the experiment. First thing in the experiment. Oh, I forgot to bring up the experiment. I thought I had it up here. Let's see if I do. Oh, here it is. Okay. So vinegar, ammonia. I'm going to slide this out of the way just so we can see what's going on. I'm going to do them in the order of the experiment. There is 0 order to this. In my classroom, I did not set up 12. I had 12 lab stations. I had 6 peninsulas with 1 station on each side. And so I would try to set up 12 stations. Sometimes it's hard with sensors, to get that many. But now here's the other thing. When you catch the bulb on the edge of the test tube or the flask or the beaker, you can break the bulb. So you just have to be careful. So I'll put that in, and I'm going to start collecting data on your end. By the way, you should see graphical analysis now says collecting. That means that, you're getting data from me. You just haven't quite got it yet. With events with entry data collection, 0 anxiety. I'm watching this meter at the bottom of my screen. And when that pH stabilizes, I'm going to tap keep. And I'm going to type in that this was vinegar. Now, if I hadn't set bar graphs off by manually, oh, here, it's telling me that right now. It's saying, this is categorical data. Is that what you really want? Yes. And so it will actually label, you see that bar is labeled with vinegar. Otherwise, with the free version, it would only allow a number. Okay. So I'm going to take this and put it in this. I have distilled water in this beaker today. The lab calls for, the experiment calls for, this is ammonia, by the way. The experiment calls for a pH 7 buffer, it's just so the probe returns to 7. One of the reasons for that is if you are going to test things like students drinking water, these probes don't like, well, no, doesn't hurt them, but they have a hard time measuring pure water. Just not enough ions in solution usually in water. And so you can get some pretty unusual readings where it'll bump up and down. It definitely won't be 7. We get a few people that'll say, yeah, why isn't it 7? But it will, it'll definitely jump around up and down if you try to measure water samples. So in the experiment, it says to use a soaking solution and a rinsing solution that's a pH 7 buffer. But for this experiment, the pH changes so much. If you just do the, most of the chemicals here, that's not going to be a factor. So let's see, what was that I just did? Ammonia. So you should be seeing data coming. Is anybody getting any data? Anybody following along?
I'm getting data. It's updating for me.
Okay, anybody in chat, let us know. I love to hear if people are getting the data. It should be coming across the internet here. Lemon juice, let's do some lemon juice. I like to use the real deal containers. And let me explain why. Now, not so much my AP kids, but certainly my 9th graders and my less scientific students, they were certainly convinced that if it was food, it wasn't a chemical because it was safe. Think about what I just said. Right? It was not, it's a food, so it's got to be safe. Yeah. And so, it was kind of an interesting, so that's why I like to put things out in their original containers. Just because I want to convince students that everything is a chemical. Try to touch something that doesn't contain a chemical in it. I mean, there's like nothing, right? So, and then the other one here is if you're going to do this one and it calls for soda, I would suggest, because of the red cabbage, use a clear or clear-ish soda, and just for your own sanity, use diet soda, because then when they spill it, it's going to be easier to clean it up. Fresh soda is best, just because over time it's going to lose carbonation, which is really what's causing the reason why it's slightly acidic. So that one, I didn't ruin that one too bad. I can put that over ice later when nobody's looking. Okay, let's see. So that in there. Is soda good for you or bad for you? Well, I don't know. pH is pretty low. And when you're teaching pH, and each pH value is 10 times different than the one before it. Sometimes some people call it a decade. It's an interesting whole connection to logarithms and stuff like that. I'm going to talk and collect data. What's the next one? Soft drink drain cleaner. Ooh, drain cleaner. You might want to check the drain cleaner. This is diluted. I used to put it out this way for my students. The reason is that real high pH stuff is hard on the probe. It won't kill it. I mean, actually, this may not be diluted. I just saw a pretty large amount of material come through. Let's see how it looks. It can stick. This one's kind of a gel, and it can stick to the probe, and that you want to definitely rinse off real well. So you can see my distilled water is around 7-ish, probably because of contamination. Let's see what this drain cleaner is, what the pH of it is. I thought I diluted that, but maybe not. You can see pretty high pH there. You don't want to leave it in there too long. I mean, that's going to deplete the ions on the end of the electrode. And so, for the purpose of the lab, it may be okay. But honestly, if you dilute that with water, you're still going to get a very high pH. And the whole idea is for them to just get the idea of that. It's not critical that it be a specific value or anything like that. So let's see. I'm going to take it out of the drain cleaner, put it into the water, swish it around without banging it around. I want to get that pH back. I want to get the drain cleaner off the end of that. And so diluting it probably would have made it a little easier to clean the probe too. So, all right, what's the next one? Next one is detergent. What about solids? Well, I used to do aspirins, I used to do Tylenols. This, I think the detergent is somewhat powdery. Yeah. I like these little containers like this, if you can find them, rather than having a big monster thing of Tide floating around. Let me move this in anyway. And you don't need much. You know, I tell the students a pinch, they don't necessarily know what a pinch is, but size of a pea or less. The lab does have some guidances to making solutions, but frankly, it just doesn't matter for this experiment. You can pretty much, you want to compare substances, what's an acid, what's a base. And then, maybe later, like I said, look, the pH is still a little high. Let me give that a good swish. I'm going to try, I'm rinsing that off. See if I can put, if any of it's still stuck on there. Yeah, better. What did I do? Detergent? Oh, let's find out here. They do like, if you do like aspirin or Tylenol or something like that, they do love a mortar and pestle. They just see that as some kind of science equipment. Of course it is. What did I just do? Detergent. Working with the software guys to get graphical analysis to the point where when you do pick events with entry to keep a value, that it automatically jumps into the field where you're going to keep the value. There's some baking soda. I did a video some time ago comparing baking soda and baking powder. And so that's a whole little discussion of, what the difference is. There's baking soda. Let's see. That looks like. I mean, you could get to the point where you could have students read the labels and start making predictions based on what they read in the labels. That would be a really good use for a good thing to do. Okay. So baking soda, little basic, but not quite what you want. I mean, I don't know what you want, but maybe not as basic as you thought it might be. So we'll do baking soda. All right, your turn. That's the 7 that are in the experiment. I don't have another test tube. Oh, shoot. I was going to say, what else can you do? Let me just slide this over here. I'm going to move the camera over. You can do, here's baking powder, antacid. Definitely dilute this before you use it, because you can really strip the ions off the end of the electrode. It won't kill it. You can put the electrode back in the storage solution, let it sit for a while, and it will fix. It'll likely fix it, but it's hard. Really strong bleach like that is pretty hard. So what I used to do is do this, have dilute bleach sitting next to it. 10-to-1 dilution still gives you a very high pH. And here's like detergents, soaps and things. Some kids have maybe made soap and they know about the bases that you use and so forth. But you got to think about it. We used to, after the AP test, we used to have a whole unit on making soap. And do you want the pH high? Because I mean, you're putting that on your skin. So anyway, I'm going to stop collecting data. And so if you are collecting it on your end, you should now see the data on your end. Let me see what my iPad looks like here. So there's my iPad. Let me bring it over to you guys so you can see it. So if you are doing a demo at your demo table, this is my iPad right now. Oops, let me close that. Then you could do that and share the data with your students, any number of them. You can also, like I said, have one person in the lab group collecting the data and sharing it to others in the lab groups simultaneously as the data is coming in. Are there any thoughts or questions before we do the red cabbage? What else could you do besides red cabbage? Well, you might have noticed on that data sheet. Please don't hesitate to hop in if you think of something. Just break in. Don't even. It's not. I will not be offended. But you'll notice red and blue litmus is on here. You could, depending on where you are in your course, you could do Hydrian paper, other indicators besides red cabbage. I mean, there's a whole slew of vegetables and fruits that make really good indicators. Or
Hey, Noose,
Yeah.
there's a question about calibration.
uh-huh.
Do you need to calibrate the pH probe before doing this experiment? Maybe elaborate on calibration and when that's appropriate.
This experiment, no. For this experiment, calibration, unless you suspect your probe, there's something wrong with your probe. I would think not. Now, what should happen, and I don't know how badly I might have hurt my probe here when I put it in that drain cleaner. I'm definitely going to have to dilute that. Let's see how it does when I put it back in the storage solution. So if your storage solution is fresh, the probe should be reading around 4 in the storage solution. And so when you first connect your sensor, if it's reading around 4, there you go, then my guess is you're good to go for this experiment. For most experiments, you don't need to recalibrate the pH probe unless it's old or something. When do you need to recalibrate the pH probe? When you're trying to find the Ka of a weak acid. Because if you're doing it by the half titration method, you're going to find the equivalence point, and then you're going to find the volume of the pH at half the volume. So, then it has to be right because your Ka is then going to come out right. But for most experiments, believe it or not, even for normal titrations, because even if the pH was wrong for maybe, off by a half a unit or something, the equivalence point would be the same. It would just be higher or lower, but it would still be the same. So for a regular titration, you could probably get by as long as the storage solution's reading around 4, you could probably get by without recalibrating. Can you recalibrate the sensors? Of course. The beauty of the GoDirects now, the voltage output of the system and how that relates to pH is not linear. So we were faking it a little bit with our 2-point calibrations. If you did them in a narrow range, it was fine. But if you try to do over a wide range, the calibrations weren't so great. So the GoDirect sensors now give you the option to do a 3-point calibration. In the software, if you go to the calibrate option, it gives you a 2-point and a 3-point calibration option. So you can really improve the accuracy of the sensor if that's something that you want. When you do a calibration of a GoDirect sensor, either in graphical analysis or on a LabQuest, the calibration gets stored to the memory of the sensor. So once you've done it, unless you've really done something nasty to the probe, then you don't need to do it again. You can use any buffers. We sell these cute little capsules that you put in 100 milliliters distilled water. They're so simple to use. But we also I have recipes for how to make just about any buffer you want. So hopefully that answered the question.
Yeah, Noose, so remember that little bug where the bars go away? Can you show people how to toggle on and off the data that's being displayed on the graph?
So there are people out there that got the data. Yay, yay.
Yes, lots of people said they got it. So that's
great. What happened was nobody said anything, so I didn't show this. On I have an iPad, and when I was done collecting data, it was a blank graph. And I'm guessing some people have that too. And so with, a little subterfuge on my point, I went on my y-axis label. So right here where it says pH, tapped on that, open up this little window. I turned off pH and I turned on pH. We have notified our software guys that this we think is an iOS issue because we're not seeing it on computers and Chromebooks, but in iOS, for some reason, if the data disappears. So our guys will figure that out, but just tap on the y-axis, toggle the pH off, toggle the pH back on, and you should get, if you're still connected, down here at the bottom, it'll say data share. You should get the data. Good question. Sorry, I thought I was being a little sneaky.
No, I don't even think that was I don't even think. Right. I don't think that was the issue. I just think it's also good to show people how, because when you do more data collection. That's where
Right.
all the runs get stored. So it's always a good thing to do as well.
Yeah,
It's not
yeah.
just to fix a bug.
Yeah, anytime you do data collection, if you collect more than one set of data, you can tap on that and you'll see graphical analysis automatically stores data sets. If you want to see more than one on a graph, you can just, toggle, whichever ones you want to see. So that's kind of a neat thing too. And we do get that question, where did my students' grade data go? Any other thoughts? Something about icky growing mold. Oh man. So in Maryland, it's hotter and more humid than it is in Portland. And but almost every year that bottle would be black. It had grown something really nasty. We pitched the storage solution, rinse the probes off under running tap water, create new storage solution, pH 4 buffer, and 10 grams of KCl for every 100 milliliters of solution. So you either use your own formula or, like I said, we sell these little capsules, or we do sell 500 milliliter bottles of storage solution if you don't want to make it. And then the bottles, we brushed them out. Right. When I was lucky, I had lab aides, students that liked me and wanted to help me. And so, okay, take these bottles. We didn't have that many. I mean, we might have 12 or 15 pH probes, but they would, the students would brush out the bottles and fill them with fresh storage solution. But yeah, some places in the country it's worse than others. Any other questions? Is the bar graph to air? Let's say, is it possible to add air? Yeah. But Melissa's the expert on this. You want me to do something that Melissa's the expert on? Where is it, Melissa? Is it under graph options? Is it here? There is
No,
error bar thing, but where is it?
it is on.
Are you an IB teacher? The person asked us. It's it's in the data set, right?
Yeah, you have to go. You have to open the
go into
table.
the data, and then I go here.
And
there it is.
Yeah, click on the column you want to.
So let me do that again
adjust.
for you. Who was that? Christina, how you doing? Good to hear. Good to see you here. Go to the data table, tap on the three dots next to probably pH is probably what you want. And then go to column options, and it's right there. What's cool is this thing here. Melissa showed me how to do it. You can actually define how you want the error bars to work, and that's something that if you want more about that, Melissa needs to show you, because I've only done it once, but it's super cool that yes, you can do that.
Yeah, well, and it's pretty, while you have that screen up there, Noose, it's pretty self-explanatory if you want to do something really simple. So if you just want to do a fixed value, like you've determined the error of your pH probe by doing numerous runs, and you could do the average of that and put in the fixed value there. That's usually kind of the quick and dirty way to do it. Percentage is probably not as useful here, but useful in other situations. I really like to use that third option that was there, which is the use column value. And that is when you've done like 3 trials and you want to add the error of your 3 trials onto the graph. You can make a column that will be, pH error, and then you can use that. And so then it'll be different for each piece of data. But yeah, so there's 3 different ways to do it. And
do we have an article about this anywhere?
I don't know. I know we went
nice
into detail with it in one of our webinars on gas pressure. We did like the whole, I think it was the gas pressure one. We did the whole step. We walked through it, but I don't think we have like a little tech tip or anything written about it.
Yeah, that might be something to do just for folks that want to get, well, especially I think it's a lot of times it's the IB teachers, but there may be others, like Christina's very, very ambitious. So.
Yeah, maybe Dylan's listening and she can put in a good word for another tip.
You've got it.
Good. Yeah, I know. I like using the column too.
Yeah.
And that is only available. Error bars are only available in GA Pro. Is not available in the free version of the software.
Lots of other things in GA Pro too. Not a huge do I like this data? I think I do. I'm going to save it.
It's pretty. It looks good.
It actually came out really good. And so I'm going
Yeah,
to
I'm gonna save it too.
and I'll make it clean. I'll title it better later. But the other things at J Pro that you might explore, Melissa, during COVID mostly, she videoed a whole bunch of experiments. And so if you go to the first page of graphical analysis, when you first load it up, it says see experiments. This only works on the pro version. Melissa made up a bunch of chemistry experiments, that, you know, pretty common ones, but ones people are likely going to do. So like, how do you set up an acid-base titration or something like that? And it has videos in it. So it shows you, you know, during COVID, the big question was students, even with the data, they're not really sure how it worked. And so, you know, there's a video that shows you how to set it up and how to collect data and all that kind of thing. If it's time-based data, you can also synchronize it. In chemistry, that's not a huge benefit, but it does have that ability with time-based data to synchronize it. But not only can you look at the ones we did, you can put your own in. So if you want your students to maybe record a 5-second video or something that shows their setup, with Graphical Analysis Pro, up on the top right, the view options menu, there's a thing that says video, and you can add your own video if there's not one in there already. You can remove the one that's there and put your own if you want. So that's kind of a cool feature. And then, you know, some of the other things, like you can do custom calculate columns and you can do custom curve fits. I haven't found a huge use for those, but in chemistry, but you know, there is that ability. When you get graphical analysis for your school or for your department, the site license extends to everyone, not just everyone at your school, including your students. So it's kind of a pretty good deal. Okay. Is that only available in the advanced version? Grzina, are you talking about the video or are you talking about the error bar?
The error bars,
Okay.
we already answered that. Yeah. At least I hope we did.
Well, we're getting close to the end. Does anyone have any last second questions? My question to some folks, I asked it earlier, was, is anyone going to ChemEd? I'm all packed.
It's in Canada. It's a pretty big hike this time.
Yeah, this time it's a little different, but you know, they kind of got, oh, red cabbage, good point. I had a picture, I wanted to show that to you. So the way I do the red cabbage is really, really rough. We have a blender that I only used at school, and I would just grind up, I would tear up, let me get the camera up here. I would just tear up the cabbage and, you know, I have a knife in my desk and, you know, cut it up into cubes or eighths or whatever, toss it in the blender, add some water. I did it right there in front of the kids. And the red cabbage juice is pretty good at freezing. So you can make like this container, you can put it in I didn't do with a few minutes left, let's do the red cabbage. Let's do it. But anyway, let's do it. We got to talking and I forgot totally about the red cabbage. All right, here we go. It's out of the way. All right. It's one of those things where the students, can we take a picture of this? Can we get our phones out? Because I was pretty picky about phones. And you know, it's just kind of so much fun. Does stink. So, you know, you're gonna hear that. You know, they're gonna tell you about how bad it smells. But it is just, it's my favorite kind of universal indicator from food, because it just kind of makes such a beautiful array of colors. I don't know why my stirring bar got off to. I had not stirring bar, my stir rod. I had one yesterday and I managed to misplace it today. But look at that, isn't that beautiful? Let's try that one. Just kind of neat, you know, the array of colors that you get. And so, yeah, the students are going to want to take pictures of that. I have a bunch of them from my classroom from a long time ago, but making the red cabbage super duper easy. Just chop it up, throw it in a blender, add some water. I know people like to boil it and all that, and that's fine. I mean, there's no reason not to. But I mean, I just made it right in front of the kids, and then I would filter it with a big, colander type thing, and then I would just hand it out in beakers to the kids. But if you want to store it, put it in the freezer. Don't fill it all the way up, but fill it up, 3/4 or something, and then stick it in the freezer. And when just before you need to use it, pull it out. It'll be just fine. I also somewhere around here I had dropper bottles, and the problem with dropper bottles is that when you make it, here they are. Let me grab them. The problem with them is that when you make it real quick like that, you don't boil it. It's not that concentrated. And so you really, if you're going to put it in dropper bottles, then you need to make it a little more concentrated. So cook it a little bit so you can get a nice and concentrated solution. But yeah, these are little ones I used to use on shows and when I went to STEM night or something, because we would put these things out. So there you go. I used the last couple of minutes. Are there? Yeah, rose petals, blueberries. What's that plant that people have in front of their house that changes? It's like red in one pH and blue in another pH. There's some big plant. Not a very good plant person, but yeah, there's a whole thing about indicate at OMSI here at the museum, the Chem Lab. There's a whole experiment where students try different fruits and vegetables, and boy, turmeric, is that one? Yeah, turmeric changes color. So anyway, I killed all the time, folks. I'm sorry. Hydrangea. That's it. Thanks, Kim. That's the one. And it changes color depending on the pH of the soil. So that's kind of neat. But anyway, if you have any questions, please don't hesitate to contact us. Chemistry at Vernier.com goes right to Melissa and Elaine and I. Of course, you can just write to support, or you can, call us. We love to talk to people. So that's it. Dylan, is there anything else I need to say? Oh, t-shirts. Yeah, we're giving these away at conferences, right? Right, Dylan?
That's great. Yeah. So if you want to have a cool trendsetter shirt, stop by one of our booths at a conference if we happen to run into you.
Yeah, I wanted to wear a fun t-shirt because it's the middle of the summer. I want to wear it, So all right.
Great.
Have a good evening, folks. And I'll have another one of these in a few weeks on acid-base titration. But it's backwards, and it's from the new forensic book. So it's and the name of the experiment is called Messed Up Makeup. And so it'll be fun. It'll be a lot of fun. And that's in August sometime. So hope to see you guys there. All right.
Awesome.
Have a good evening.
Bye, everyone.
Bye.